Friendly libraries. I'm Eric Hodel, and so I go by Dr. Brain, and every time I've come to RubyKaigi, I've been asked to give a talk. So this is the talk for all those people who have asked. So I live in Seattle. I live with my girlfriend Jamie and our dog Cookie Pants, and she thinks your small beer cans are very cute. And also, it's her birthday next week, so if you see her, oh, here we go. So if you see her, you can wish her a happy birthday. I'm a member of Seattle Ruby Brigade. I hack with Ryan Davis. This is him with a velvet painting of himself, and also with Aaron Patterson. So I really like to write libraries. I've written a lot of libraries. I've written or contributed to or maintained about 90 or so unique gems across all the time I've done Ruby. Some of the libraries I've written are serious for real work, and some of them are jokes or silly or supposed to be funny. And so, of course, across the course of all those releases, I think I've learned quite a bit about how to write a friendly Ruby library. And so I think the first thing you should do is to follow some standard conventions that your library works similarly to the way everybody else writes libraries. And first off, for naming a library, I think you should use, put an underscore between the words in your name and then map that to the class so that it's easier to go and figure out what file to require and what class would show up. And if you're writing an extension for another library, you should put a dash between the original library's name and your extension. For the structure of the file, executables go in bin. The library name follows the library, or the file to require follows the library name. All the extra files go in a subdirectory with the same name. I put the extension in a subdirectory as well, so that I can have a smaller part in C and a larger part in Ruby. And you should have a test for every class that you have. And I put the test underscore in front so that it's easier for me to autocomplete in Vim or tab complete, and it also matches the way autotest works out of the box. I also use semantic versioning as much as I can. For semantic versioning, you have three parts. The largest part is which API compatibility revision you have. For the second part is for new features that you add, and the final part is for any bug fixes you make. And so you increment those depending on what things are in your release. And so here are some examples of techniques that I use to make my libraries easier to use. Not every technique is necessarily appropriate to every class you may write. The first one is have good behavior. Your users are going to expect your libraries to work a certain way, so try to behave in a way that they would expect. Use common naming so that if you're writing something that looks like an I/O, then implement methods on it that make it behave like an I/O. Also, Ruby has programmed many brains, so take advantage of that. If Ruby behaves a certain way, then follow those conventions. When I first use a library, I like to experiment with it and explore how the library works. So I define 2S and give it some kind of meaningful, readable output. If I'm writing some tests against a library or using a library and I use it in my tests, I implement inspect so that it has some useful debugging information. And if I have a very large set of objects that are all interdependent, then I implement pretty print so that when you go and you can get a large readable output. Make sure your objects are properly comparable. So define double equals to make equality work right. If your objects are ordered, then you should define spaceship and include comparable. And if you can use your objects to match with other objects, you should find the triple equals method and equals tilde in order to do the matching. So for comparable, you define the spaceship method and you get all of these comparison methods out of it. So here's an example out of Ruby in the IP addr class. IP addresses are sortable, so you include comparable and you define the spaceship method. And if the objects aren't comparable, in this case they don't have the same family, the address family, then you return nil. Otherwise, you just return -1, 0, or 1, depending on the ordering of the two objects. You should also make your objects hashable. You should define the hash method and the EQL method to mark the two objects as unique as a hash key. And this allows you to use things like put a bunch of objects in an array and call unique on it to get a unique list back. Or you can use the array difference and intersection and union operators to filter two sets of objects. If your object behaves like a collection, you should make it enumerable. Define each and include enumerable, and then you get all the enumerable methods. And also, if the objects are ordered and you have spaceship defined, then you can get min, max, and sort. So here's an example. This is kind of a dumb class. We have a class that stores a list of months with the month number and the name. And so we can define each, which will go and yield each month number and each month name, and we also include enumerable. And so then we can do something like find all the month names that end in ARY. And so we use select for that out of enumerable. There's also enumerator, which allows you to create many enumerable methods on your object. So in your enumerable method, you call enum4 and return the enumerable object it created. And also the enumerator that returns is both enumerable and chainable. So you can do a thing like take your enumerator, map it with index. And so you can map and also have all the indexes of each item. And so here's an example of how to write it. I define each month, and then if no block is given, I make an enum4 here. And then otherwise, I go ahead and yield the month, just the month name. And so the enumerator will call back into you with a block to go through the second path. And so with this, we can write, we only have to deal with the month names now. So when we're selecting all of our month names that end in ARY, we have much simpler and cleaner code. And you may want to provide many of these for all of your different ways you might want to enumerate the object. So when you have a library, you're going to have some exceptional cases that you may not be able to handle, you need to pass back to the user. And I think the most important thing when implementing an exception system in your library is to have a common subclass that all of your exceptions inherit from. This allows you to do things like break apart exceptions in the future and still have old code work. So they'll still rescue the superclass. Your exceptions should also say why you have a problem rather than just what went wrong. If that's possible, in order to go and help the user of your library figure out what they should do. And if possible, you should attach data to exceptions. So when Ruby raises a name error, it'll give you the name of the constant or the method that it couldn't find. So you can go and take that out, and instead of having to parse the exception message in order to get that data. There's also initialize copy, and initialize copy is called from both dupe and clone. And so if you have to do something special when you're going and copying the object, you can put it in here, it'll work for both sides. You can do things like, you may have deep structure that needs to not be edited or changed across your objects, and so you can go and take care of that initialized copy. Also, you may do something like have a registry of objects that's outside of the one you're copying, so you can use that to update that shared cache or shared state. I like to use Marshall a lot. I've used it in both RDoc for the RI data and in RubyGems for all the gem specs. And it's a way to save and load objects. It uses a compact binary format, and it's, as far as I know, it's still the fastest way to get objects, load and restore, or save and load objects in Ruby. So some guidelines for using Marshall: you should always have a version in your Marshall data. So that way, if you change something in the future, you'll have backwards and forwards compatibility. I like to dump to an array or a hash. That way you can go and have some meaningful information behind your data, even if it's just an array index. And I like to use Marshall dump over underscore dump. Marshall dump makes a slightly more compact representation than underscore dump does. And so with the version allows compatibility. So whenever you add new data, you should increment the version. And if you have some old key, you should never go and change that to maintain backwards compatibility. If you no longer need the data or you find it's wrong, you should instead add a new key or a new item. So as you're developing your software over many iterations, there's going to be bugs that you find that you may have added in accidentally, or you may want to stop maintaining your software because you're not interested in it anymore. So I like to make my library as maintainable as possible so other people can fix bugs, or if I need to hand it off to someone because I'm not interested anymore, that somebody else can pick up from where I started. So libraries that do one thing and do one thing well are the easiest to write. And I think they're the easiest to understand because there's less written, and so there's less there to go and look through when you're trying to go and change something or fix a bug. It's also easy to get a stable API faster because you just do less, and it's also easiest for other people to reuse in a larger library because they won't have extra baggage that comes with the library. Release notes, I think, are probably the most important part of maintainability. Release notes gives a story of how your software developed over time. So that you should have all the important things that are going on in your library. What new features you added, what things changed, if you fixed any bugs. And it should look more like the news file in Ruby and less like the changelog. So you don't want to have the user going and digging through all of the commits that may have been added and then reverted and then implemented a different way. Instead, they should just have, this thing was added. I think tests are the second most important. You should definitely write tests for your library and make sure that you run them constantly and that they always pass when you're doing releases, especially. Be sure to test everything in your app. They define the behavior and set the expectation of how your library is supposed to work. They can also help you refactor the API, so you may be writing some tests and find that it's hard to test the feature that you want, and maybe that's a sign that you need to break the API apart there or add some helper methods to eliminate the clumsiness of your API. And you should also have an abstract test case that ships with your library. It provides a sandbox for running your library. So that way, you've got all the utility methods in there for creating any mocks or stubs or any other thing you need in order to test your library. And I like to put my test cases in the lib directory. That way, if somebody wants to write, say, an extension to Ruby gems, they can take the gem test case and use that to go and write the extension. And they don't have to redo all the work that I've already done to make the library easy to test. When you write executables, they should be small. That you should have all of the work that your library does in lib. That makes it easier to test. So you can test all your command line options, you can test all the behaviors that your library has through the application. And this is what I mean by a small executable. So we have the shebang for Ruby, we require the file that we need, and then we pass off to run. So that everything, all the option processing happens in lib, all the behavior happens in lib. And so as your library grows, you're going to have, you may end up having incompatible changes. And so this is a little bit harder when your library is small, but for a larger library, you can separate the API parts from the implementation parts, and then hide the implementation details. So this way you can define backwards compatibility at the API layer and then have the implementation details change as you need to. And also having less API classes makes maintaining backwards compatibility easier because you have less interface between your internals and the user. I'm not very good at C. I'm probably only okay, and I think that most Rubyists don't know any C at all. So when I try to write C extensions, I make them use as little C as possible. So I implement as much of my extension in Ruby and use Ruby as a glue between all the pieces in the C extension. And I think that since more Rubyists know Ruby than know C, this is a much better way to provide maintainability and allow other people to fix bugs in my libraries. It's also easier to refactor the Ruby parts than the C parts for me, and I think that's true for most Rubyists as well. And of course, you want to document your libraries, and you want to try to document the API and hide any of the parts that are the internals and that the user shouldn't use. You may want to document those anyways for developers, but not expose that to the users themselves. If you don't think you're very good at writing documentation, you should at least provide examples, because everybody who writes Ruby can read Ruby as well. And so through examples, they can go and figure out how your library works, even if you may not have very good documentation. So many of the things that I've already talked about cover how to make your library extensible, but behaving like Ruby and writing tests. But there are a few other things you can do. You can write some hooks, and hooks allow you to change the way the library runs or behaves, so you can go and say, well, the user may want to do this extra little thing, so we'll go and add a hook for that so they can expand upon the library here. And the easiest type to implement is the callback. RubyGems has several callbacks during the install phase, one that happens before the installation, one that happens before the gem is usable by the user and one that happens after the install is finished. And the middle one can be RubyGem's test uses in order to run the tests, and if the tests don't pass, then they can go and ask the user, hey, do you really want to continue to install this, or do we want to cancel out and figure out what's wrong? The other method is to allow the user to subclass a class in your library, and then either override a method or call a method in order to register some new behavior. And it's not always possible for the user to go and simply hook in all the time. For example, RDoc or RubyGems is often run as a command. So you can provide plugins to register these hooks for the user, and so that way the loading happens automatically. And RubyGems provides a method to help you with this, gem find files. And so this example is from RDoc. For RDoc, there's a special file that you put in your extension called RDoc Discover, and RDoc will automatically load that. And then if there's any problem with it, it will warn and say, hey, we couldn't load it, and give you the reason. And this way, RDoc loads plugins that the users provide. And I think the part of writing libraries that seems to get the least attention is actually doing the release. So when you're doing a release, you should provide a README, and you should include a description of the library, a link to the bug tracker, and a link to the source repository, so the user can either file a bug or try to fix some problem that they found, and also provide some examples to go and get people started with using the library. You should have release notes, and release notes should say why you should or shouldn't upgrade your library, so I can go and read those and say, well, this bug has been fixed, or an incompatible change has been made, so I should or should not release. You should include what's changed in the library, what's new, so new features, and what bugs have been fixed. And you should also have links to the bug tracker for all these things, so that if you want to go and if a user wants to find more data, they can go and look through the bug tracker and see what the fix was or whether it addresses their issues. And so when I release, I do all these things. I make sure that the tests pass. I make sure that I'm shipping the right files. I make sure that then I go and create the gem and then upload the gem to rubygems.org. I tag the release in the version control, and then I go and upload documentation. And I do all of these things much less frequently than I do writing a library. And so since if I were doing them by hand, which I did long ago, then it was easy for me to mess up and forget a step and then have a bad release. So instead of doing all this stuff by hand, you should use a library to go and eliminate the manual labor. And so since manual labor you can get it wrong, if you have everything automated, then you'll make less mistakes. If you have some piece of some task or some extra thing that you may do, don't go and copy and paste that between all your rake files, because it's not going to be the same. Instead, go and put that in a shared rake file or put that in a library that you load in order to help you. So that way everything is the same when you do the release, and you have fewer accidents and surprises and bad releases. So I use Hodel to release my software, and I type rake release and give it a version, and then it checks everything that it needs to be checked, does all the uploads, all the announcements, everything. Ho has lots of plugins, so if it doesn't behave exactly the way you want, there's probably a plugin to either add the feature or change the behavior. It's very customizable, so you can go and change how different parts work. And also it follows the dry principle. There's a single location for all the data that Ho uses and pulls, so you don't have to go and edit things in multiple places for the same change. And these are some of the Ho plugins that I use. I use the Git plugin for the projects on Git. I use Isolate for some of my projects to go and have a safe set of dependencies. I use Minitest for almost all the libraries I develop now, and I also use the email plugin to help me write announcements. So I think there's one thing that's more important than everything I've said when writing friendly libraries, and that is to have fun. Ruby is supposed to be about having fun, so be sure to take time and enjoy yourself when writing the libraries. Thank you.
はい、それでは質問を受け付けます。Do you have any question?
You said that you should use. I'll be a little bit troll right now. You said that you rather prefer use news instead of changelog, but news and changelog are totally different files and with different purposes. Why you are convincing people to use news instead of changelog?
So when I go to look at changes to a piece of software, I want to know the important things that the author of the software is telling me. And I don't want to have to dig through the changelog to say, the changelog may say, well, we added this feature, and then we found a problem, and then we reverted the feature, and then we added it in a different way. So having to sort through all those things by reading the changelog is difficult for me to figure out what went wrong, or what changed or what's new. If instead it just says, we added this feature, then I have to read less. And if I'm interested in the changelog, then that can be kept separate, or I can go to the source control page on the project and I can look through all of the changes. But I think it's very nice as an author for them to provide the important things first, and then if I need more details, I can go find those.
Okay, I only clean up this. News file is usually for API users, changelog for developers.
Yes.
And I have second questions at this point also. You said that it's better to write as less C as possible in C extensions, but the main reason why we are using C extension is efficiency, and efficiency can be achieved only by writing writing more in C than in Ruby.
So the question is why do I say write less C when there's an efficiency issue? Not every C extension is about efficiency. MySQL, Postgres.
Actually, that extensions should be as efficient as possible.
Yes, but they are also wrapping up a C library. So there are two types of C extensions, some that are wrapping a C library and some that are written for efficiency. And it depends on what your goal is. I write a lot of wrappers that are not meant to necessarily be more efficient. They're meant to expose functionality that is found in a C library that I don't want to implement in Ruby. I wrote one for the OS X pasteboard that allows you to cut and paste data between applications the same way you do with Command C and Command V. And that one is not interested in efficiency at all. So I only have to write the parts that talk to the C interface and expose those to Ruby, and then everything else can be in Ruby.
Okay, thanks.
まだもう少し時間がありますけれども、質問のある方いますか？じゃあ前の方。
Do you have any advice on collecting user feedback from your library users?
So advice on collecting user feedback.
Yes.
It's difficult to get user feedback sometimes. One of the strategies to do is to make pre-release versions and say, well, I'm going to change all these. This is a big change, so I'm going to release a pre-release version, and Rails does that. But because it's a pre-release, not necessarily everybody uses it. So it's difficult to go and get the announcement out. Having the bug tracker be in a common location that people like to use is important. Until recently, GitHub Issues didn't have as many features for managing the issues as the old RubyForge bug tracker did. So the RubyGems project used the old one, and people didn't like that one. So that was kind of a barrier. So you may need to kind of accept that you're not using your favorite tool in order to appease your users so that they can go and give you feedback better. Being active on mailing lists is also helpful so that users can see that, hey, I can go here, and when somebody asks me about my library, then I can go and respond to it or direct them to the bug tracker if it's an issue that they need to file. So it can be difficult to engage people in that way, but pre-releases, having a bug tracker in a common location, mailing lists, Twitter, and so on can help you go and help the users find where they need to go to help you.
Thank you. Yes. Oh, by the way, which is your favorite, GitHub or RubyForge?
By now, GitHub is much better than RubyForge. They now have all the issues and the labels, and you can do the assignments and the milestones. There's a few issues with the milestones still, but I think overall now GitHub and GitHub issues are much better.
Thank you.
はい、他に質問ありますか？あ、いた。
Where is the good location of data resource file you read from library code?
So where do I put shared data? Yeah. So RubyGems has I forget the name of the method. I think it is datadir, and you can go and put those, I think, in the share directory in your gem, and then you can look that up at runtime to get the current location of that. So when you have multiple versions installed, it'll pick up the right shared data path. And I think that's gem datadir is the method name, and the path you use is share, but I don't use it very often, so I can't remember exactly.
Thank you.
他にありますか？いない。いないみたいですね。いないですよね。はい。Thank you.
Thank you.
Next speaker, Richard. Please check your machine condition. 11時半から、始めますね。後ろの扉は使わないでください。